Only write down what you need to. Congruent polygons have congruent parts. Their angles match, their sides match. They have the same measure. Our rigid transformations made congruent polygons last chapter. When you name congruent polygons, you have to list the vertices, the corresponding vertices, in the same order. Order matters. So for example, how should we name this first polygon? What order should we say its names? A, B, C, D. So if we say A, B, C, D, and we want to state that it is congruent to the other trapezoid next to it, we have to be very careful to list them in the right order. So FGHE is what has been suggested. FGHE. Okay? We're going to check. First of all, how could we get from here to here? What kind of transformation was that? A way? Reflection. Okay? So we reflected. If we reflect this, then I agree. A and F are congruent angles, because rigid transformations preserve size, shape, angle measures. Okay? You said B is congruent to G, and you're right. And we mark that with double tick marks. Okay? You also said C is congruent to H, 3 ticks, 3 arcs. And then finally, D is congruent to E. So far, so good? Do we need more time writing, or are we okay? We're good? Okay. So when you have congruent polygons, when they state that they're congruent, they can ask you to name the corresponding sides, and they can ask you to name the corresponding angles. So which side do we want to start with? AB. Segment AB would be congruent to which segment? FG. Okay. We can show that by a single tick mark for each one. BC would be congruent to what? HG. If Brandon had said GH, would that be okay? Is HG and GH, are they the same segment? So it's okay if we interchange the order. Okay. How about DC? What is it congruent to? EH. Very good. And finally, our last side, AD congruent to EF or FE, depending on how you write it. Okay. So all 4 sides, all 4 corresponding sides are congruent to 4 corresponding sides. We can also say that their corresponding angles are congruent. So which would be congruent to angle A? Angle F. We show that with 1 arc. How about B? Angle G. Okay. Next we have C. finally, angle D. So you'll have a problem like this in your homework. List the corresponding parts, the corresponding angles. Okay, just one of them, fortunately. A lot of writing, but we want to make sure you understand that. Okay, the neat thing is you don't have to have a figure in order to be able to pick off the corresponding parts. So Ian, give me 3 letters. A, B, C. Ryan, give me 3 other letters. H, I, J. If we write them in that way, then that tells us which angles have to be congruent and which sides have to be congruent. Okay, Maddie, which angle would be congruent to angle A? Perfect. Michael, what angle would be congruent to angle B? Maddie saw that A was the first one listed, so she listed H. B is the second one listed, so I. And that's how it will work for these. Angle C, what do you think, Braxton? And we can do the same thing with the sides. Liz, which side will be congruent to AB? There's AB. Which side's going to be congruent? So HI. Okay. T, which side is going to be congruent to side BC? IJ. Yep. IJ. Very good. Okay. Piper, which side will be congruent to side AC? HJ. And we could do that again if you want. But is everybody okay? You're good with how to name these? Okay. So let's not take the time. So here's a congruent polygon issue. Okay, we have the wings of an SR-71 aircraft, a Blackbird aircraft. And they suggest congruent triangles. So we think that these may be congruent triangles. I'd hope so, right? Because isn't an aircraft symmetric on both sides? So here's our line of symmetry, our axis that, or our line that we're reflecting across. Okay. So angle A would be congruent to which angle? D, right? This would be a reflection. And angle C, this angle, would be congruent to which angle on the other triangle? F. And finally, the top angle B would be congruent to what? Yep. So if they ask us what's the measure of angle D, I have 30 degrees at E and B. I have 65 degrees at C. So where should I put my 65 degrees in this other triangle? At F. And we know D and A are congruent. So how can I figure out how many degrees is the measure for angle D? Good. 65 plus 30 plus x equals 180, because yesterday we said the angles of a triangle, the sum of the interior angles of a triangle is 180 degrees. So I've got 95. If 95 plus x is 180, what's x? 85. So angle D has a measure of 85 degrees. Are we good? Okay. So then they can throw some more variables at us, make sure that we're honing our algebra skills. So they tell us that trapezoid DEFG is congruent to trapezoid SPQR. And we're to find the values of x and y. So do you notice that we have an x here, right? And we have an x and a y here. Let's try to find x first. Okay? 2x minus 4 is the measure of QR. Which side is congruent to segment QR? FG. So here's FG. Can someone give me an equation that relates those two? 2x minus 4 equals 12. That's what it means to be congruent, right? They have equal measures. So now it's an algebra problem. 2x will be equal to 16 when we add 4 to both sides, so x equals 8. Now we're trying to find y. Y is down here, 6y plus x. That's the measure of angle Q. Angle Q will be equal to what? F. How much does F measure? 68. But don't stop here and don't let this scare you. We have an x and a y here, don't we? How can we solve that? Substitute 8 in for x. X is 8. 6y plus this 8 is 68. Taking the 8 to the other side, 6y is now 60. So y is 10. Okay. We all good? Don't let it scare you just because we have x's and y's together. Are the following triangles congruent? I hear a yes. Does everybody agree? Okay. How could we justify that? How could we explain it? All sides right now, we're still just starting this out, and we won't want to have to prove this every time. All sides have to be congruent, all angles have to be congruent. Coming up, we'll have some triangles that we'll prove, and we'll be able to shrink it down and use less information. We won't have to have 3 pairs of sides and 3 pairs of angles. But for today, to let you feel the pain of having to prove them all, we're going to ask you to show all sides, all angles congruent. Great question. Okay. So what do you think? Okay. All sides, all angles. So do we have all sides, all angles congruent? Or can we get there? We've got a 6 and a 6. So this has got our single tick mark. Here's a double. I like that. 6 equals 6, right? And the 4s are equal. I like that. So we can get all 3 sides congruent to all 3 sides, right? Okay. What about angles? Okay. A and B added up have to be equal some number. 180 minus that number would be what C is. And E and F are those same ones, right? So 180 minus that measure would also be equal to C. Why else is C equal to this angle at C equal to this angle at C? They're vertical. Vertical angles are congruent, okay? So, yes, all 3 pairs of angles are congruent, and we have 3 pairs of sides congruent. Okay, so far so good. All right. So next, Derek alluded to the third angle theorem. The third angle theorem says that if 2 angles of one triangle are congruent to 2 angles of another triangle, then their third angles have to be congruent to each other. We have 180 degrees, right? So if we have a pair of angles in one triangle congruent to a pair of angles in another triangle, then there's nothing left but, you know, because of the 180 degrees, those third angles have to be congruent as well. So if we have a figure like this with triangle ABC and triangle EDF, since A and E are congruent and B and D are congruent, C and F will have to be congruent. Good. Now, the next thing coming up is going to be a proof. And I don't want you to formally prove the ones that we have today in your assignment. What I want you to do is just be able to kind of explain why these triangles are congruent. Okay, it doesn't have to be a formal 2-column proof. So we're going to walk through what we're looking for here. Okay, so if we had this figure with these marks, could we prove triangle ACD congruent to CAB? Yes, Brandon says yes. I agree with him, but let's explain why. BA is congruent to DC, given, right? And why does the third line have to be congruent? The third angles do by the third angle theorem, but does the third side have to be congruent? Not necessarily, right? We don't have a third side congruent, but do we have a side that's used by both triangles? And it's equal to itself, isn't it? So when we get ready to formally prove something like that, we'll get to use reflexive. Remember that big table of things that we could use: transitive, symmetric, reflexive, and so forth? Reflexive was one we hadn't used before because we never really had a time when we were saying something was equal to itself. Okay, now these will overlap or connect, so we'll be able to use reflexive. Okay, so yes, AC equals itself. Rewrite that better. And then we're on a roll here. We've got 3 pairs of sides congruent to 3 pairs of sides. What else? How about that third angle? So we have an angle A at A, DAC, congruent to ACB. Why do I have to name it with 3 letters? Because there's 3 angles here, right? An acute angle and acute angle and the 2 of them together. So we have to be careful to name them correctly. And then we have an angle here at DCA congruent to CAB. So how can we get our third angles congruent to each other? Because of the restriction of 180 degrees, right? So could we simply say we have a third angle theorem that forces those 2 to be congruent? Angle D and angle B are congruent by the third angle theorem. So we'd be good. So I want you to strategize on these proofs, okay? Don't have to write the full formal proof, no 2 columns. Just tell me what you're thinking. How can we get it there? Okay? All right. Assignments on the board. You've got some time to get started or finished if you've been working. For origami crane, 4 through 16 even, and 26 through 29 on page 243.